Now let's take a look at dividing rational expressions. So this is going to turn out to be very similar to multiplying rational expressions. So let's take a look at a very simple example from our past. Let's say 1/2 divided by 1/3. So again, still two fractions, but this time we are dividing. Now if we really thought about it, it's 1/2 divided by 1/3. But making this super fraction really isn't the best way to go about it. Okay? Now if we think back, if we take this 1/2, dividing and multiplying are actually very similar. They're kind of connected. We can change this dividing into a multiplying by its reciprocal, its opposite. So if we flip the second fraction to now a 3/1, we can change it into a multiplying problem. And when we do that, we get 1 times 3 is 3, and on bottom 2 times 1 is 2, 3/2. So really all we're going to do when we see a division problem is flip the second fraction and make it multiplication and do it like how we've already done it. So 10x over 9 divided by 5x squared over 12. So I notice that it is division. I don't want division, so what I'm going to do is flip the second fraction and write it as multiplication. So keep the first one how it is. I'm going to make it multiplying by flipping the second fraction. And now we go ahead and see if stuff simplifies, multiply together, see what we can do. So 10 and 5, so that makes a 1 and a 2, dividing both by 5. The 9 and 12 both divide by 3, so here's a 3 and here's a 4. This 1x will cancel with one of those, so looking all together, we've got a 2, a 4, a 3, and 1x left over. And I guess this 1. So multiplying all that out, on top, a 2 and a 4 make an 8. On bottom, we have a 3 and an x. So that's the way we can apply the stuff we learned the other time from multiplying in order to get these very similar answers here. Alright, for example, let's say they give us x squared minus 2x minus 15 over 8x plus 20 divided by 2 over 4x plus 10. Now remember, we don't really want to ever work with division. We want to flip this second fraction and make it multiplication. But you see, there are some things we do need to factor, because this, once it turns to multiplication, there are factoring that we have to do. Factoring before we can cancel stuff out. So x factoring this top one here, it's a negative 15 on top, but negative 2 on bottom. The two numbers that complete that would be a negative 5 and a positive 3. You see they multiply to give me negative 15 and add together to give me a negative 2. So written out, that is x minus 5 and x plus 3. On bottom, we'll GCF out a 4, leaving me with 2x plus 5. Now remember, this one I'm going to flip, so I'm flipping and factoring at the same time, so this is now on the top. Factor out a 2, leaving me with 2x plus 5, and on the bottom a 2. And now let's cancel things that appear on top and bottom. 2x plus 5, 2x plus 5, 2, 2, and doesn't look like anything else came out. So you can either go back to this original how it was or leave it how it is right now. X minus 5, x plus 3, and the only thing left on the bottom is the 4. And there we go, we got our final answer. So once we're able to change these from division to multiplication, then things are a lot easier, a lot similar to what we did the other time. Alright, step up the difficulty. 3p squared plus 18p minus 21 over 3p minus 3 divided by 16p minus 32 over negative 2p squared plus 10p minus 12. Alright, remember we don't like that multiplication, or we don't like division, sorry, we're going to flip this second one to make it multiplication. We do have to do some factoring. Alright, so I'm looking at the top here. There's 3 pieces, but I don't want to x factor that just yet. Remember, try GCF, see if we can knock the numbers down. So we can actually take out a 3 from all of these. So it leaves me with 3. So taking a 3 out, we have p squared plus 18 divided by 3 is 6. 21 divided by 3 is 7. On bottom, we'll take out a 3 from that. P minus 1. So I'm going to make this a multiply. Now I'm flipping this, multiply and flipping. Alright, so now this is going to be the top, and I can factor out a negative 2 from here, leaving me with p squared minus 5p plus 6. And now this is the bottom, take out a 16, leaves me with p minus 2. So I've done a little bit of factoring. I haven't fully factored because obviously I still have to do an x factor here and an x factor here just to continue the process. So x factoring on the top, negative 7 and 6, that is made up with a 7 and a negative 1. So you got p plus 7, p minus 1 over the 3 and the p minus 1. Now we're starting to see things that will cancel. Over here we do our x factor, we get 6 on top, negative 5 on bottom. The thing that completes that would be a negative 6 and, ooh, actually not that combination, a negative 3 and a negative 2. P minus 3, p minus 2, 16, p minus 2. So now we've done all this factoring, and the great thing is once all this is done, it's really satisfying now to see everything that cancels. P minus 1, p minus 1, p minus 2, p minus 2, this 3 and this 3. The negative 2 and the 16 simplify a little bit by 2, so that's a negative 1 and that's an 8. And then I kind of identify everything that's left. I got the p plus 7, the negative 1, the p minus 3, and this 8 on the bottom. So a negative sign, a p plus 7, a p minus 3, and on bottom, all that's left is going to be that 8. And there we go for our final answer on that one. So the thing to remember here, and the reason it went so fast, is because anytime we have dividing, we don't actually do it as division. We want to take that second fraction, flip it, make it multiplication, and now it's similar to the problems we've done previously, where we factor, we cancel stuff out, and everything's easy to do. But remember, anytime we have division, flip that second fraction, change it to multiplying.